We're at Triangle Lake, Oregon. It's a large lake. It's about 95 feet deep, but it used to be about 20 times larger. We're in the Oregon Coast Range and in the area where there are steep-sided valleys and no means of forming a lake by most common means by a glaciation creating a moraine which dams up a valley bottom which creates a lake basin. Here instead we're in a place that has never seen glacial ice, at least in the last several million years or so. Instead, the lake was formed by a large landslide which came off on the hillside just behind us and swept out into the lake, creating hummocky terrain. And that created a large dam in a very steep-sided, canyon-y kind of landscape. And the water backed up about 15 kilometers. And it has been filling in. The landslide, we believe, happened about 45,000 years ago. And most of Lake Creek Valley is the infill that's occurred over that time. So the lake is filling in here from the far side out towards the outlet and will eventually all become floodplain and wetland. Coring again begins by lowering this down into the sediment or just above the sediment, then tying the cable off so that the piston is stationary. You tie it off onto a cleat on the platform. Then you lift the square rod 1 meter up and you turn it clockwise a quarter turn and drop it into its locked position. Then you push the coring tube down past the piston and sediment enters the tube. Then you're able to untie the cable and pull the whole contraption to the surface. And once it's on the surface of the platform, it comes up the hole here, and then you lay it down horizontally like this, and you reset the square rod and you place it here, and then this is on the rafts again. So by pushing this back in this direction, the piston is being pushed down the tube and your core falls out onto a tray, right onto your platform. And then you're able to describe the core, wrap it up, and store it. Then you have to clean out the core because it gets muddy on the inside. And then you're able to lower it down the hole and take your next meter.
In this segment, we're showing an example of casing. Casing is not necessary unless one is coring in deep water, but it is fundamental to the deep water coring process. It is important because it prevents currents from affecting the coring equipment as it is being driven down and retrieved. It also enables the coring equipment to go down in the same place over and over again, so that you're going down into the same hole in the lake and creating a continuous core in which the bottom of one core segment is continuous roughly with the top of the next core segment. Each casing piece is 1 meter in length.
Okay. So this piece is called the collar, and the collar is what holds the casing at the surface of the plywood platform. So attaching the collar is always great satisfaction. So now you know the rules about always holding it by the cable. Consider the cable the line to your climbing partner. You're belaying down the cliff, and it's attached to their harness.
If I let go?
If you let go, they fall. Meanwhile, the drive rods are also attached to your climbing partner, but the drive rods are a noose attached to a noose around his neck. So you never want to pull on the drive rods. So that's the, so I'll let you, if you can, what you can do is hold it so the threads are right up here,
Okay.
and then you can keep it from twisting by pushing your toe against it, like that. Okay, so now we've got rod 2 here. So this 2 meter tape means that it's 2 meters from this tape down to the bottom of the Livingstone core. Okay, so now you can lower away the cable. And now you hear water entering the core tube. And then,
Tell me what I'm doing. I'm just keep doing this.
yeah, there you go. So it'll say 3 and 4. So
Oh, that way, yeah. Now you can just go that way.
the rods are like 1.6 meters long, but there's tape every meter. Yeah.
Oh, I see. I see. I just didn't want to hit anybody.
Yeah.
I.
Whoops, that was my fault. Okay. Now we're going to 1120, right? There we go. Okay, so why don't you put the 20 centimeter mark above 11, the bottom of the tape.
20 centimeters above the water?
Yeah. It's right there. Okay, so right above the white tape. Okay, that's great. Dry rods. Okay, so now we need to push down to that point. Okay.
Right there?
Yeah. Okay. Now I tie the cable off. This cable on this side, so we shift around. Nancy, do you want to set the square rod? You know what that means by now? Yeah. So, yeah, so you pull it up 1 meter. Yeah, it's heavy.
Oh my lord! Tell me when it's a meter.
You'll hear
Oh,
it
a click?
there.
And
Now
then I do it.
clockwise, that way. There, and then drop it down.
Okay.
There.
Good.
Great.
Awesome.
So now that 1120 mark is now up here, and we push back down to it. Okay.
You ready?
Yeah. Okay, 1, 2, 3. Push hard.
Right. Another centimeter.
by pumping water into it by lifting the square rod up and down. So now it's full of water. And then I lift it up and quickly turn it upside down, and eventually muddy water falls out. So that was pretty clean, so I'm just going to fill it up and I'll take the next core. Okay. All right. Want to lift it with me?
Yeah.
Okay. So. And as it's going up, we will let the cable fall into the water on that side. Okay, so up, and then lift. Oh, let me know where you're at. Okay. Sometimes you don't want to lift it so high that, yeah. Problem, sorry. There you go. Okay. Oh, I don't like this wind. Okay. Oh. Let's get that cable in the water. There we go, mud on the rods.
Just cleared out for that one.
All right, last rod. Okay. 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 Oh, sorry. Of course. Okay. Hey, there's something there.
It's a great band.
Yeah, sometimes the core is a little bit longer than a meter. It's usually contamination at the top anyway, so it's all right. Excuse me. If you can scrape that band with your knife so we can get a view of that. So we're only 100 meters offshore. I'd expect large flood events to have washed organic debris down a small creek and leave layers in here. So yeah, yeah. So what we probably have there is, now this is a really good sign because it's just a half a centimeter thick, completely horizontal. It suggests that there is, minimal disturbance to the core itself. Even though the rest of the core is very uniform and we don't see many features in it, could be because either there's this mixing process at the mud-water interface which is continually occurring, so that there's always some sort of like constant depth that's being mixed as sediment's being deposited. Or it could be because the sediment is the same every year and there's nothing changing year to year. And you can't tell the difference until you actually sample your core and start measuring things. But here we have this layer, this organic band, that's not mixed into the core at all. It's just like this flat layer. So to me, that suggests that throughout the core, it's probably similarly nicely horizontally deposited material, and there's not a lot of mixing going on, which is great because we're only in 8 meters of water, which is deep by many people's standards, but it's not the deepest part of this lake. And a lake this size can have wind-generated currents, which can, get oxygen to the bottom of the lake, or even create enough current at the bottom of the lake to disturb the sediment, which is why people prefer smaller lakes. The sediment is so silty and uniformly fine material because everything that's big is sorted out and deposited near the shore. So we're not that far from the shore, but we're far enough away from the shore that everything large diameter has fallen out and only silts come here, except for this one event when there was probably a flood which brought it in. Whether it came in from this hillside or whether it was something massive that came from up valley, you won't know until you do lots of cores of a lake. So there was a study done in Vermont on the East Coast where people obtained many cores from many lakes, and all they did with the cores was identify these layers of organic matter, these storm deposited layers. And they developed a time series, a long record of these layers, and showed that throughout the last 10,000 years there were these periods of time when storms were much more frequent, and they were almost cyclic on like 1,000-year cycles. So that's kind of one inference you can make from these layers if you have lots of data. However, if you just have one core, well, it tells you a storm happened then and it deposited a bunch of stuff. But at least it's like maybe there are conifer needles and seeds and things in there that we can identify, which will tell us a better picture of the vegetation at that time than the pollen will, because it gives us, the needles give you a species level identification, while pollen often only gives you a genus level identification. So it tells you which tree species were occurring just right here. So I'm very pleased to have that layer in there. It's really great. What we have here is a Livingstone piston core, and we use this to collect sediments, soft sediments from the bottom of lakes. This has been the standard mode for coring lake sediments for approximately since the late 1960s. We work on a platform like this, which is attached to inflatable rafts, and we core through the center hole through casing into the bottom sediment. The difficulty with coring sediment, which can be up to 50, 60 feet of sediment at the bottom of a lake, is that you can only recover a meter at a time or short drives at a time. So you have to return that down to the same hole and collect the next meter and continue coring. This core device operates by a piston at the bottom, which prevents sediment from going into the tube until you're ready to core. And that's the whole purpose of it. There is, I will take it apart to show how it operates, but essentially this a square rod piston core operates with this square rod which slides up and locks out of the way and then allows the piston to travel up the core tube when you're ready to core. I'll show you the parts of the Livingstone piston core by taking off the 3 screws that hold the head onto the core tube. So and I don't have extras of these, so I have to be very careful with them. Okay. All right. Okay, so now we have all the parts of the Livingstone to see, and it's not too complicated. The piston, 2 rubber gaskets which can be tightened, which adjust the friction inside the core tube. By just squeezing them, you increase the diameter. The cable attached to the piston, which travels up through the head and then continues up to the surface coring platform. Then you have the square rod, which has a connector to the drive rods, which attaches to the square rod. The action here is that in one position the square rod cannot slide down, but in another position the square rod can slide through the head. So when you're coring the lake, you lower the core down to the depth where you want to start to begin to core. And I may not show this very well, but what you can't see is what's going on down below, is that you begin with the square rod down, holding the piston down at the bottom of the core tube. Then you tie the cable off so that the piston becomes stationary with respect to the vertical dimension, with respect to the top of the lake. And then you lift your drive rods up, which pulls the square rod up out of the way, and then you turn it and drop it in. All the while this is well underwater and you're many, many feet above, okay? Now you have it set up so that when you push down on the square rod, you're going to be pushing the core tube down and the piston's going to remain stationary. So you're pushing the tube past the piston and sediment has to go into the tube. Okay, so that's what you have to keep in your head while you're working on the surface about what's actually going on down well below your feet where you can't see what's going on. So that's essentially the operation of the core tube. You only have the cable and the drive rods are the only thing you're holding on the surface. So I'll reassemble it and go over it one more time. That's not good to have sand on there. Thank you, Aaron. The longest someone that I know of has cored with this device is about 20 meters of sediment. And after a while, the friction of the lake sediment becomes too great for you to continue to core.